Okay, in this video, we're going to work two of the most challenging exponential equations that we could ever be asked about. So in this case, we first start out with just 2 to the x equals 3 raised to the x plus 1. Our first instinct, hopefully whenever we have exponential equations, is rewrite each of these so you have the exact same base on both sides. However, we run into a problem in this one because we can't rewrite 2 as 3 to a power, can't rewrite 3 as 2 to a power, and those are both prime numbers, so we can't do any nice factoring to begin with. So the next thing we want to do is whenever we have exponential equations is we could utilize a logarithm on both sides. One-to-one property of logarithm says we're allowed to apply a logarithm to both sides as long as it's to the entire side. So I chose the common logarithm. Kind of looking ahead, eventually we may be asked for an approximation utilizing our calculators on this one. So I would either choose the common log, log base 10, or the natural log, the ln, log base e. All right, so why I'd want to do this is because when you apply a logarithm to both sides, now that a logarithm is involved, we get those properties of logarithms. So the big one that I want to focus on is the one that says that if you have a power attached to everything on the inside of the logarithm, that's allowed to come down in front and become a multiple. Same thing on the right-hand side, we have x plus 1, a power attached to everything on the inside. That's going to come down in front and become a multiple. So on the left side, I can say this is x multiplied by log of 2 equals, on the right-hand side, be careful, that entire exponent comes down, so it's x plus 1 multiplied by log of 3. Okay, from here, it doesn't look like it, but this is actually just a linear equation. Your variable x is only raised to the first power. This variable x over here only raised to the first power. So that's a little bit tough for students to see sometimes and work through in their head because it looks a lot more difficult with these logs hanging out. But treat those like they're constants or numbers. The next thing I'm going to do is on the right-hand side, go ahead and clear out our parentheses, distribute. So on the left side, we have x log of 2. On the right side, I'm going to say x multiplied by log of 3 plus 1 multiplied by log of 3. I don't really need to put that 1 out in front here. Okay, so we have a couple terms that have x's. We have another term, this log of 3, that doesn't have any x's. The next thing we want to do is get all of the x terms to the same side. So I'm looking at this x log of 3. Let's move it to the left-hand side. So to do so, I'm going to have to subtract it from both sides. Hopefully we're following along. I subtract x multiplied by log of 3 from both sides to move it to the left-hand side. We still have that log of 3, that last term that I'm bringing down here. Now, it's a process you've done hundreds of times in the past, but it looks more complicated because we have these logs hanging out here. But looking at these two terms on the left-hand side, they both have an x. So what we want to do is factor out a common factor of x. So x comes to the outside, and that's going to have to be multiplied by, think to yourself, x times what gives us this first term. So it's going to be x multiplied by log of 2. And x multiplied by what gives us the second term. So it's going to be minus log of 3 equals log of 3. Bring that down from the right-hand side. So now on the left-hand side, we have x multiplied by a big set of parentheses here. So x is connected with multiplication to everything else on this side. To get x all by itself, we simply need to divide both sides by log of 2 minus log of 3. And we'll do the same thing on both sides, log of 2 minus log of 3. Staying consistent, doing the same thing to both sides. That will isolate the x on one side all by itself for us. Now we can clean up our answer on the right-hand side a little bit. I notice in the denominator we have 2 logarithms that are subtracted. So we have some properties of logarithms that say we can put these together into one logarithmic function. We can say that's the log of 2 goes in the numerator, 3 goes in the denominator. This is our division rule for logarithms, or quotient rule. 2 was positive out in front, so it goes in the numerator. 3, that logarithm was negative out in front, so the 3 goes in the denominator. Just to be clear, this is an exact solution that we just found. We could also get an approximate solution by putting this into our calculator. So an approximate solution that goes right along with this would be negative 2.7095, just rounded off there. All right, not an easy problem, but you have all the skills to get through this because you know about properties of logarithms, about moving exponents down in front, and you factored out a common factor before, so don't let this throw you off too much. It just takes practice to get really confident about these. Let's work through one more problem that's very similar as far as it goes. This time we have 5 raised to a power and 4 raised to a power. So in getting moving the right direction on this, can't rewrite 4 as 5 to a power or 5 as 4 raised to a power. So let's apply a logarithm to both sides. Again, I'm just choosing the common logarithm, log base 10. Nothing all that special about choosing that versus the natural log. They'll both get us to the exact same correct answer. They'll be equivalent even if it's written with natural logs as opposed to common logs. Our next step, use those properties of logarithms, move these powers down in front. So we can say, remember, it's x plus 2, that entire exponent multiplied by log of 5, equals x multiplied by log of 4. Next, a little bit of distributing, clear out the set of parentheses on the left-hand side. We can say x multiplied by log of 5 plus 2 multiplied by log of 5 equals x multiplied by log of 4. On the right-hand side, just brought all of this down. Next, notice we have 2 terms that both have x's, one on the left side, one on the right side. I'm going to elect to put these all on the same side. So I'm going to move this term over to the right-hand side by subtracting it. So I'm bringing down the 2 multiplied by log of 5. And then I'm going to have x multiplied by log of 4. We said we were subtracting that x multiplied by log of 5 over to the right-hand side. This puts both of the terms that have x's on the same side. Here's the big challenge is you have to remember we factor out that common factor on the right-hand side. So being that they both have x's, x comes out. We'll be left with log of 4 minus log of 5 inside that big set of parentheses. Okay, to finish this up, to get x on one side all by itself, x is connected with multiplication on the right-hand side. So we're going to divide both sides by that. What's inside the big set of parentheses, log of 4 minus log of 5. That'll allow us to cancel those out, get x on one side all by itself. We can make this look a little bit nicer if we wanted to. Maybe you say log of 5 squared or log of 25 up there in the numerator. For the time being, I'm just going to leave it as is. And then the denominator, I will clean this up a little bit and go ahead and say, well, that's log of 4 over 5 is a little bit cleaner answer instead of 2 separate logs being subtracted. Combine these together using that quotient rule. So again, exact solution where we are here. We can put this into our calculator and get an approximate solution. I got this to be about negative 14.425. Exact solution, approximate solution. Usually seeing this the second time through makes it a little bit easier. Practice these up, get comfortable with these properties of exponential functions and logarithmic functions, and you'll do great on this. Good luck.